Hello. All right, last type of solving trig that there is going to be for this unit is solving using the quadratic formula. This one has a y equals. Y and 0 are interchangeable if you remember from Algebra 1. So sometimes they'll give it to you in terms of y, which is no big deal. You're just going to replace it with a 0, okay? And then theta or x, whichever one. In this case, I think it was supposed to be x, but I put theta. Okay, doesn't matter. They're variables. Okay, so let's just try to solve this the way we have been solving. So 3 equals tan squared theta. So we start this and we're like, wait a second, tan squared. How do I do that? Okay, so in order to do this guy, we're going to go ahead and do the quadratic formula. So I moved it over here and I kind of got myself stuck, which happens a lot when we're solving these things, which is totally fine. So we're going to go back to our original. And then I'm also going to put in a non-squared, except for it's going to be 0, non-squared thetas because there are none of those, okay? Minus 3. So if we were looking at this in terms of A, B, and C for quadratics, A would be 1x squared, remember tan and x are all interchangeable, so I shouldn't say interchangeable, but they work the same way. If this was a x squared plus 0x minus 3, we could solve this using quadratic and say, okay, our A is 1, our B is 0, and our C is negative 3. Okay, so when you get to something that looks scary, again, like I keep saying over and over and over again, make it into something that's not scary. This, you guys can solve. You guys have been doing that for years. This is a little bit more daunting, okay? So same thing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So same thing we're going to do here, except for instead of x equals, it's not x, it's tan. So we're going to say tan theta equals x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we get equals 0 plus or minus the square root 0. And then when I do quadratic formula, I like to count the number of negatives just because it's so easy to lose your negatives. So I have 2 negatives, which you could totally see that, can't you? Let's make this brighter for you guys. I don't know if that's going to help at all. So I have 2 negatives. What's a negative times a negative? It's a positive. So then I make this into a plus. So then I don't lose that sign accidentally. So now I have 4 times 1 times 3. So I get positive 12 all over 2a. Do you guys know that song? I hope you do, because otherwise you're like, what is this woman singing? So 0 plus or minus, so we don't care about that guy. We're going to say plus or minus 12 over 2. I can simplify radical 12, so let's go 2 and 6, 2 and 3, pairs of 2 come out, root 3, so we get plus or minus 2 root 3 over 2, 2's cancel, so here are my 2 ratios. I'm going to have tan equals positive root 3, and tan equals negative root 3. So let's go ahead and do our triangle. We're at a positive, well, we're at both. We want positive ratio and negative ratio, right? Let me get a little bit more paper for us here. So let's figure out, we got our all students take calc. We essentially have 2 equations we need to set up, right? We have our tan theta equals a positive root 3 over 1. And our tan theta equals a negative root 3 over 1 because we're looking at the plus and minus. So there's the plus, there's the minus. Okay, so if we're looking at the positive, all students take calc. This one's going to be in quad 1 and 3. Tangent is O, so what triangle do we know that has a root 3 and a 1 in it? That's a 30, 60, 90, right? So in this case, the opposite is root 3 and the adjacent is 1. I sure hope you guys can't hear my kids running like crazy herd of elephants upstairs. So what angle is that? Opposite of a root 3? It's 60 degrees. Okay, so if I'm in quad 1, we have 60 degrees. If I'm in quad 3, we go 180 plus 60 degrees, we're at 240. That's just for this first guy. Now we got to do the second guy. Okay, I'm going to do that guy in, let's do pink. Okay, so this is a negative, so we're going to be in this guy and this guy. So we'll go ahead and draw a triangle here. Same thing. This is going to be a 60, root 3, 1, right? So 0 to this guy. So we're going to go 180 minus 60 degrees. That's going to be 120. Oops. And then there's going to be one down here, which is going to be all the way to 60 here. So that's going to be 360 minus 60. We get 300. So my theta values are 60, 240, 120, 300. And if you read the directions, if it's a free response question or fill in the blank, it says to arrange them from least to greatest. So make sure you guys are doing that with no spaces. So 60, comma, 120, comma, 240, comma, 300, comma, no symbols, no spaces. This would be your answer if it was a fill in the blank one, okay? Let's see if we have another one. We do have another one. Okay. So this one has an x squared or cosine squared. So we need to do Pythagorean theorem, or not Pythagorean theorem. We can't do Pythagorean theorem. We need to do quadratic formula. So just like, let's write what this guy looks like. 2 weird variable squared plus 2 weird variable minus 1. If I gave you this and told you to do quadratic formula, you would be able to do that no problem, right? So quadratic formula is x equals, this is going to be cosine x or cosine theta, whatever your variable is, equals negative, let's see, a, b, c, negative b plus or minus the square root, b squared minus 4a, c, all over 2a. Negative 2 plus or minus the square root of 4. Again, I count the negatives, so I have 1, 2 negatives. So 2 negatives is going to make that into a plus. And then 4 times 2 is 8 times 1 over 4. Negative 2 plus or minus the square root, 12 over 4. Okay, we got that lovely square root we can simplify again. So that would be, I'll do it the other way just in case you guys don't do the factor tree we just did. This is the other way to do it. Doesn't matter which way you do it, whatever you prefer. So we get 2 square roots of 3. So negative 2 plus or minus 2 square roots of 3 over 4. Because it has a plus or minus in there, in order to cancel these guys out, we have to do what I call the V cancel. That's definitely not a mathematic term. We have to take something out of every single term. So remember, pluses and minuses makes it into a term. So this is one term. This is a second term, okay? So that 4 we can cancel out. So if I were to reduce that, 2 goes into all of those. So this would become a negative 1. That's a 1, and that's a 2. So we get negative 1 plus or minus root 3 over 2. All right, well, what reference triangle is that? Yeah, that's not a reference triangle that we know of, right? So we need to do our cos inverse. Okay, and it became cosine because we did the, I keep saying the Pythagorean theorem. We did the quadratic formula, right? Okay, so let's figure out what that guy is. Grab my calculator. Let's figure out what that guy is equivalent to. Figure all that out. So I'm just going to do one at a time. Turn that off so you guys don't have a glare. Okay. Negative 1 plus, we got to do one at a time. Square root of 3. And then I'm going to push enter because it's all in my numerator. If you guys wanted to put it all in at one time, you need to put parentheses around your numerator, okay? Or else order of operations would come into play and give you the wrong answer. So that's my numerator, and then I'm going to do divided by 2. So I get, for one of them, for the plus, I get cos x equals 0.3660. Okay, and then we're going to do the minus one. So let me show you how to do it with parentheses if you want to put the whole thing in. So the parentheses keys are right above the 8 and the 9 here. So we would just do parenthesis -1 minus square root of 3, and then exit, get out of there by arrowing, close your parenthesis, and then divided by 2. Because remember, order of operations says multiplication and division first, right? So let me just do that without the parentheses quick. So we want this all as one term, which means we're doing subtraction first. But if we don't have the parentheses in there, it's going to be root 3 over 2 first, and then -1 minus that value. Okay, so it's going to give us a different value. Okay, so we want this guy with the parentheses, or like I said, do the numerator and then divide by that denominator value. So the other cos value we have, I'm going to put it over here. The other cos value we have is -1.8. Oh, sorry, wrong one. 0.3660. Okay, so we have two values that we can't do triangles for. So we need to do the cos inverse. So we're going to say cos inverse of this guy. And then cos inverse of, whoops, should be an x. It doesn't matter if it's an x or a theta. It's a variable. It's not that big of a deal if they're interchanged. They mean the same thing. Okay, so on our calculator, we're going to do cos inverse, so second cos. And then we have the 0.366 value. So we get 68.5309. And then we're going to do the same thing over here. So in order to not type that all over again, you can push the second and the enter button, and it brings up the last equation that you put in your calculator. So that's kind of a nice shortcut. Okay, so cos inverse, and then I just need to change this guy to -1.3. There you go. So we're going to enter that guy. Okay, and then this one, we get a does not exist, which we've had before. So this one's fine. So for that value, we're not worrying about that. Okay, so this guy, don't even have to worry about it. Just this one. All right, we're not done yet. We have to figure out what quadrants we get a positive. This is a positive decimal. So where is a positive cosine? All students take calc, so we're here and here. Okay, so 68, that's good. That's quadrant 1. And then we need to go all the way to here. So we're going to go 360 less 68.3 or 53. So 360 less 68.5309. And we get 291.4691, which makes sense. 291 is this in quad 4, so we're good there. Okay, so these are our answers. So these values work. Just because we get a does not exist here does not mean the whole function doesn't exist. These two values will work in the function. Okay. That is it for solving trig. Solving trig equations, I should say. But wasn't it fun?